Good evening, everyone. This is Unit 4 of IAL Physics, June 2015. In the first question, the number of neutrons in a nucleus of AU 197. So, how to find number of neutrons? So, nucleon number minus the proton number will get the number of nucleons. So, C is the right answer. Which of the following is a possible unit for rate of change of momentum? Rate of change of momentum, that's called force, because force is mv minus mu over t. So, and the unit of force is Newton, but SI unit, the base unit, Newton itself is force meter, kilogram, meter per second square, because it is mass into acceleration. So mass is kilogram and expression is meter per second square. So C is the right answer. It will be kilogram meter second minus 2. A positron enters a particle accelerator. As it emerges from accelerator, its mass measured to be 3.8 into 10 power minus 29 kilogram. What we can conclude, because mass of proton and mass of electron as well as positron is 9.11 into 10 power minus 31 kilogram. That is a rest mass. But this value, so what it shows it is moving close to speed of light. Relativistic effect is there. So that's why C is the right answer, that it is traveling at a close to speed of light. That's why the mass appeared to increase. A particle of mass m carry a charge q are traveling with the speed v. They enter the magnetic field of flux density v at a right angle. This causes the particle to move in a circular path. So here the centripetal force is equal to the magnetic force. Centripetal force is given by m v square over r, and magnetic force is q v b. So v will cancel with v. So we can say mv over r is equals to qb. Or we can say mv is equals to qb r. Or mv over qb is equals to r. So which of the following change would decrease the radius? If we increase the mass, radius will increase, so that's not answer. If we increase the charge, if we increase q, the r will decrease. That's true, because they're inverse relation, so B is the right answer. For question 5, 500 microfarad capacitor is charged to a potential V1. A second capacitor of 50 microfarad is charged with a potential V2, so that the two capacitors stored the same amount of energy. So energy stored in capacitor 1 is same as energy stored in capacitor 2. Energy, we know the capacitance, so it is half. Q is equals to energy is half Q into V, or Q is equals to CV. So it will be CV square. So it will be C V1 square, and this will be half C2 V2 square. Half will cancel with half, so it will be C1 V1 square is equals to C2 V2 square. C1 is a capacitance for the first one, 500 micro, so 500 into 10 power minus 6 into V1 square is equals to second capacitor 50 into 10 power minus 6 and V2. We want V1 over V2, so V1 square over V2 square is equals to 50 into 10 power minus 6 divided by 500 into 10 power minus 6. 0 will cancel, so 5 divided 1 by 10 or 0.1 will be final answer. For question 6, a beam of antiproton enter the magnetic field, causing to change the direction. So when we apply the left hand rule, if it was a proton, first finger represent the, if magnetic field should be perpendicular. So it can be A or B. So if it was out of the paper, first finger represent out the magnetic field, second represent direction of the particle. So if it was proton, it should go because the Fleming's left hand rule, the first finger represent the magnetic field, the second finger represent the direction of the particle, and the thumb will represent the force or the deflection. So when we apply the rule, if a magnetic field is out, the first finger should point out, the second represent the direction of the particle, so proton should go down and anti-proton should go up. But it is opposite is happening, so it means the magnetic field is not out, magnetic field is in. So when magnetic field is in, proton will go up and anti-proton will go down. So B is the right answer. For question 7, students suggest that two colliding proton could undergo the interaction. Which of the following statement is true? Interaction is not possible because the charge is not conserved. That's wrong. Why? Because the charge is conserved. +2 here and +2 because neutron does not have charge. The interaction is not possible because the number of the particle not conserved. Interaction does not depend on the number of the particle conservation. The colliding protons must have high energy. They should have high energy because two protons are producing more particles. So they should have a high energy. That's why C is the right answer. So their kinetic energy will convert into matter or mass, which result in formation of more particles. The graph shows how the magnetic flux passing through a coil vary with time. Which of the following graph shows how the magnitude of EMF induced in the coil vary? So as the magnetic field is changing, change in magnetic field induced EMF. So it will start not with a zero value, it will start a value above zero, because whenever the change in the magnetic field start, there is induced EMF, so we'll get certain value, and because the slope is continuously increasing, so EMF will continue to increase. So B is the right answer. For question 9, which of the following is the correct statement about the momentum in this decay? So the diagram shows a track of the particle detector. The lambda particle has decay to at point O and into two particles P and Q. Which of the following statement is correct? The total momentum of a system is zero. Total momentum is not zero because if the particle was initially moving, if the two particles were moving in opposite direction and interact, then total momentum will be zero. Momentum of P is equal to momentum of Q. We cannot say they have the same momentum because they don't have the same curvature. The track curvature is not same for both, so we cannot say they have the same momentum. The sum of momentum of P and Q must be zero. It should not be zero because they are moving in a certain direction. The sum of momentum in P and Q must equal to lambda. That's true because the total momentum before is equals to total momentum after the collision. Which of the following must be correct statement about the energy? The total energy of P and Q less. That's wrong. The total energy is conserved, so total energy of P and Q should be equal to lambda. So B is the right answer. So this was June 2015 Unit 4 of IAL Physics.